look at how we can build a cars finder agent with the help of Scrapegraph and CrewAI. So we'll look at how we can build an AI-powered car recommendation system that scrapes real-time listings from cars.com with the help of Scrapegraph, stores them in MongoDB, and gives smart car suggestions with the help of CrewAI and Nebius Token Factory, all in this clean, streamlit dashboard. So you'll be able to find the best car options within your budget, mileage, and city using real-time AI reasoning and memory. So first, let's look at the architecture of this entire agent. So here for the tech stack, as we've already mentioned, we're using Scrapegraph, CrewAI, Nebius Token Factory, and MongoDB. So initially the user can they can send an input like, I want a BMW car between having a price range between $20,000 and $80,000. First, what we'll do is at our orchestrator logic, we'll first just specifically look at our MongoDB and check for records of data based on the user's input query, which are making direct queries with the help of Python-based filters, and it will give you the response if it finds data. But if it doesn't, then it calls our car advisor agent that is powered by CrewAI, which has a bunch of different tools. Now, one of the tools that it has is a web scraper tool that's powered by Scrapegraph. So in this case, the user's input will be sent as input parameters, and on basis of which we'll be able to use the Scrapegraph tool to look at cars.com and find the relevant cars. Once that data is retrieved as JSON objects, that gets stored into MongoDB, which is another tool that our CrewAI agent has, and it will save that. And now using the final tool, it will be able to retrieve the most appropriate cars from the new listings that have been saved, and it will give a response back to the user. So it's a combination of both making direct database calls and being able to orchestrate with the help of multiple tools with the help of CrewAI. So that's the architecture. Now let's also take a look at our code and the live working demo. But before that, let me also quickly give you an introduction to Scrapegraph. So it provides a bunch of different types of web scraping APIs. It's completely open source as well, with more than 20,000 GitHub stars. And it has a bunch of different types of ways in which you can use the scraping. So it has a smart scraper. Then it also has something called as an agentic scraper that can actually navigate and interact with websites and automatically give you responses. It also has like crawlers and a simple scrape function as well. So it provides all of these different capabilities, and you can just get started with the free API key. And this is what we are using for being able to scrape our data today for this app. Then of course, all of your JSON documents are going to be stored in this cars DB collection. We have a bunch of different collections in this particular database, in which we'll be storing the data that's scraped from Scrapegraph, and then it's stored here, and then it's queried to be used in our app. And finally, we are using the Nebius Token Factory LLMs. So this provides a bunch of different open source LLMs that you can use with different kind of capabilities like text-based embeddings or even vision-based models that you can choose. You can also fine-tune your own models and host it and start using them. So in order to get started, again, just sign up for free, and you can choose any type of model that you use depending on your own availability or use case. So that being said, let's also take a look at the live demo before we jump in and explain the code. So right now I have my Streamlit app running on port number 8501, and here this is how it looks like. So we are using two different API keys in this case, which is the Nebius API key and the Scrapegraph API key. You just save them, and here you can see like right now we have no data in our database, and the workflow is that we enter our keys, we describe the requirements of the car, and then we press enter. So here, let's go ahead and describe. Let's say I said, I want a Toyota car with the price range between 20,000 and 80,000 USD. So of course, initially, it does not have any such data. So if you look carefully here, because there are no cars that are found in the database, it will start to actually scrape this particular page from cars.com, and it automatically extracted the keyword Toyota, and it's now going ahead and running the Scrapegraph tool to be able to scrape it from this particular site, and it's also inserting the documents inside of MongoDB. So if I go ahead and refresh my MongoDB page here, we should start to see some of these car listings being populated in our database here in the car listings, and you can see that we have 107 different documents. And here you can get the details of the URL, the image URL, the location, the price, and the title of all of the different types of cars. So it's scraping all of them here, and once it completes the scraping, then you'll be able to see the responses coming here. So you can see like a total of 129 different documents were uploaded, and here you can see that it gives us the responses based on the cars that were retrieved. So these were the list of all the cars that were from Toyota, and you can find that the ones matching our specific needs for these price ranges as well. So what it does is it uses Creo AI to automatically identify what are the set of cars and the documents that need. So of course, this way you can very easily leverage this agentic system that understands your requirements, breaks it down as natural language, and then automatically gives you the responses. Let's take a deep dive into how the code is actually working out. So here we have the app here, and our main brain behind the entire app is this agent.py, which is a Creo AI. So here we have initially gone ahead and imported all of our dependencies. Now, if you're also interested in the dependencies, so we have Streamlit, and then we have Creo AI tools, and ScrapeGraph and Light LLM to be able to use Nebase token factory models. So going back to agent.py, we are just going ahead and importing all of these, and then from our DB, which is another particular Python file, which is primarily for doing CRUD operations based on our database. So in this case, we provide our MongoDB URI, our MongoDB DB name, then we connect to our MongoDB instance. We create three different collections, which is the cars, the scraped pages, and then we have functions to upsert the documents, to find the cars, and also just check whether our database is up and running. So these are the functions that we are importing inside of our agent.py. Now, we also set our Nebase API tokens. Here we are using the Hermes 70 billion parameter open source model from Nebase Token Factory. We also set our ScrapeGraph API key and the specific URLs from which we want to actually seed or find our data. Now we have a large system prompt that is for our agent, and which says that it's a reliable car recommendation system, and we'll store all the listings in MongoDB. And we need to follow this tool, these particular rules, and how we should generate the responses. And then we have specific functions to do things like scraping the cars. So here, in case we don't have existing data in our database, then we'll use this particular tool. So in this case, we are using the ScrapeGraph API to find the data. So here we use the ScrapeGraph tool that we have defined, and we give the user prompt, the API key, and the website URL, and it generates, scrapes the data. And then what we're doing is that once it has cleaned all of this data, created a good JSON document, then we are storing all of that data into our MongoDB. Then we have like specific functions to scrape the seed pages and also format these over here. And then we also extract the brand key name from the input that is given from the user. So here, when we said Toyota car, you saw in the response here that initially it was able to scrape that. So that's where we're extracting the keyword. Here we have a function to get our Nebase Token Factory LLM, and this is our main Creo AI agent. So this is the main agent where we pass the LLM as the Nebase LLM. We provide a goal and a backstory, and then we create different kinds of tasks. So here we have the task to give a recommendation on what are the cars that are available and the guidance. And then here, this is where we basically create the actual Creo object where we provide, okay, like what is the agent, what are the different tasks that it has up its sleeve, and finally we kick off our Creo AI agent. And then in our app.py, this is where we have Streamlit app. So we have our Streamlit where we also import our agent as well and our database. And here you'll find all of the left hand side details that are there in the menu bars. And then finally when it comes to the main input, this is where the user is going to provide their requirements. And based on these requirements, we go ahead and kick off our agent and we get the response. So here we just have given how the responses should be generated. So this is primarily for getting all of the cars that are retrieved from the database, and the rest of the response is given to us by the agent and how it basically finds the most relevant set of cars for the user. So this is a quick overview of how things work, and of course how we are leveraging ScrapeGraph API, MongoDB, and also Nevis Token Factory to intelligently give you the responses. Now, for example, if of course, in the first time it directly used the ScrapeGraph tool, but now if I just go ahead and refresh, and if I ask the same question, maybe I can change the question a bit slightly. I can say between 20,000 and 40,000, or maybe like 30,000. This time, because it already has the data in MongoDB, it wouldn't necessarily have to use the ScrapeGraph tool again. So it directly just queried it from MongoDB because you already had that data existing. So this way you don't have to each and every time scrape the data. You can store it efficiently inside of a database like MongoDB and then start to use the app. So this way it can give you cached responses very quickly, and you don't have to wait for about like 2-3 minutes to get the scrape data and start using this. So it's a smart scraping tool and a smart cars finder agent that uses RAG and dynamic scraping to give you the responses. So thank you so much.